Welcome to The Explainer. Today, we're diving into something super cool. We're bridging that gap between everyday backyard hobbies and, well, actual rigorous science. We're looking at a fascinating experiment from a cultivator named Eng, all centered around sesamum-indicum. Yep, the sesame plant. You know, if you've ever tried to grow absolutely anything from seed, you already know it is almost never a straight line to success. It's more like a giant puzzle of soil, water, light, and a whole lot of patience. In this explainer, we're going to walk step by step through Eng's trials, unpack the specific roadblocks, and see exactly how a truly data-driven gardener turns a totally imperfect harvest into an absolute goldmine of botanical insights. Let's get right into it. So, we've absolutely all been there, right? That classic Instagram versus reality moment. You see these gorgeous, vibrant pictures of plants online, and you think, hey, I can totally do that. Well, Eng started this first batch of sesame seeds with that exact expectation, hoping to cultivate a plant with beautiful, lush foliage. But the reality? It was kind of a different story. Now, the plants actually did reach maturity. They successfully bloomed and even produced seeds, which is great. But physically, the leaves were incredibly thin and super sparse. It was definitely not the picture-perfect aesthetic Eng had hoped for. But instead of just throwing in the towel or, blaming a lack of a green thumb, Eng did what any good observer does. Stopped and asked, why? Because even though the plant did its biological job by seeding, its physical structure was telling a really important story about its environment. And that brings us to the real culprit behind those sparse leaves, a concept called a microclimate. Now, a microclimate isn't about the general weather report for your whole city. It's the highly localized set of atmospheric conditions exactly where that specific plant is sitting. Think of it like this. It's the difference between that shady, cool corner of your patio and the completely sun-baked center of your lawn just, 10 feet away. It encompasses the specific temperature, humidity, wind, and light that literally a single square foot of space receives. Eng brilliantly figured out that while the overall macroclimate was totally fine, the specific microclimate for this first batch of seeds was just simply not optimal. Okay, so what was actually missing from that environment? Well, Eng dug into the research and pinpointed two absolute non-negotiable requirements for Sesamum indicum to really thrive. Number one, full sunlight. These plants crave direct, unadulterated solar energy to push out dense, lush leaf growth. And number two, adequate nitrogen. Nitrogen is basically the powerhouse nutrient for foliage. Without it, plants end up looking really spindly and weak, which, if you think about it, perfectly aligns with Eng's reality of those thin, sparse leaves. Now, discovering your plants are starved of light and nutrients. That might feel like a failure to a lot of people. But actually, scratch that. This is a fantastic data gathering moment. By figuring out precisely what went wrong, Eng isolated the exact variables needed to fix it. This wasn't a defeat at all. It was literally a diagnostic triumph. And this realization led to a massive shift in Eng's whole approach. There's this really fantastic quote straight from the journal. For now, sesame has replaced basil and celosia as my go-to plant for seed germination experiments. I mean, that is a real game changer right there. Eng isn't just looking at sesame as some random one-off plant to grow for fun anymore. Eng recognized the immense inherent value of Sesamum-indicum as a baseline test subject. By pivoting away from old favorites like basil and celosia, Eng is standardizing the testing process, basically adopting a brand new biological canvas to run future microclimate experiments on. But you might be wondering, why sesame? What exactly makes it so special that it completely dethrones the reigning champions of Eng's garden? Well, the logic behind this shift is actually super fascinating. When we compare basil and celosia directly to Sesamum-indicum, the perks for a backyard scientist become incredibly clear. First off, cost and availability. Sesame seeds are highly affordable and extremely easy to find, whereas other seeds can be kind of variable depending on the season or the supplier. Next up, the germination rate. Sesame boasts a fast and really high germination rate, meaning you're not sitting around for weeks just wondering if your experiment even started correctly. And finally, the life cycle. Because sesame is an annual plant, it does the whole shebang, from seed to bloom to producing its own seeds in just one single growing season. For anyone running experiments, that is absolutely crucial. It means you can observe the entire life cycle and gather a massive amount of data in a very short time. It is, quite simply, the ultimate seed trial plant. All of this naturally builds into a highly structured approach. What we're actually looking at with Eng's journal isn't just a casual gardening diary. It's the scientific method playing out in real time right there in the backyard. Step 1. Grow batch 1. Observe how it matures and note the physical traits, like the fact that it's seeded but completely lacked that lush foliage. Step 2.
analyze and diagnose the issue. Ang directly connected those sparse leaves to a microclimate deficiency, specifically lacking full sun and nitrogen. And then step 3, which is the most important part for any focused learner, iterate. Take that hard data from batch 1 and use it to directly inform the planning of batch 2. There is literally no guesswork happening here. It's just a direct logical progression from observation to hypothesis to the very next phase of testing.
Which brings us to the really exciting current state of Ang's backyard trials. Based on the promising baseline results from that first batch, Ang hasn't wasted any time. Batch 2 is already fully underway, but this time around, the microclimate itself is the primary variable being manipulated. Ang is intentionally testing different environments outdoors, exposing this fresh batch of sesame seeds to varying levels of full and partial sunlight. The goal here is highly specific, to see if making these precise little tweaks to the outdoor microclimate will finally yield that dense, lush foliage that went missing round 1. It's a beautifully simple but incredibly effective way to put that hypothesis to the test. So we're all kind of left eagerly waiting for Ang's next update. Will varying the outdoor sunlight finally create that perfect Instagram-worthy foliage? Well, time and the data will tell. And honestly, this perfectly illustrates what I really hope you take away from this explainer today. Whether you're trying to cultivate sesamum-indicum or you're just learning a really complex new skill, every single attempt gives you data. In gardening and in structured learning, there are really no mistakes. There are only valuable data points that help guide your next attempt. So I'll leave you with this to think about. What data are you currently gathering in your own life? And even more importantly, what is your next backyard experiment going to be? Keep observing, keep iterating, and never stop learning.